Welcome to Education India. In this video, we are going to deal with calendar problems and the various concepts and approaches to solve any problem related to calendar and finding the day of any week. This is the first part of a two-part video series. The next part of this video series will deal with the questions that are often asked in competitive exams, and this part will deal with the various concepts and approaches to solve all those problems. Now let us start with some basic concepts. Now what we are going to follow in this video is a pure conceptual and analytical approach rather than the use of formulas. A general observation states that if the first day of any month, suppose January, is Sunday, then 8th January, 15th January, 22nd January and 29th January will also be a Sunday. As we can see, the difference between 1st and 8th is 7. Now these 7 days constitute a week. Hence, we can say that the day of the week on 1st will again repeat itself after a time interval of 7 days. Hence arises the concept of odd days. What are odd days? The number of days exceeding complete weeks are known as odd days. Mathematically speaking, suppose the number of days in calculation is 12. Its remainder when divided by 7 will give you the number of odd days. Suppose the number of days in our calculation is 37. Now 37 can be broken up as 5 into 7 plus 2. This 2 will be the number of odd days. Again, mathematically speaking, when 37 is divided by 7, the remainder is 2. Hence, we can see that there are 2 odd days. Similarly, the remainder when 69 is divided by 7 is 6. Thus, if the number of days in our calculation is 69, there will be 6 odd days. One important thing to keep in mind while solving problems is that 7 odd days constitute one complete week. In problems, whenever we see that there are 7 days in any calculation part, 7 odd days will add up to one complete week. To make it more clear, we will see it in the subsequent examples. Now, while solving problems, the basic step is counting number of odd days. First of all, an ordinary year has 365 days, as you all know. It can be broken up as 52 into 7 plus 1. This one will be the number of odd days. Thus, when 365 is divided by 7, the remainder, that is 1, will give you the number of odd days. A leap year has 366 days. It can be broken up as 52 into 7 plus 2. Thus, when 366 is divided by 7, it will give the remainder as 2, and this 2. Some people have some confusion related to leap year. Just to clear that, if a leap year is a non-century year, it has to be divisible by 4. If it is a century year, it should be divisible by 400. Suppose 1972, it's a non-century year, so it should be divisible by 4, and hence 1972 will be a leap year. Whereas 1100, it's surely divisible by 4, but since it is a century year, for 1100 to be a leap year, it has to be divisible by 400, not 4, because it's a century year. So 1100 is not a leap year. So there are some examples: 1972, 1600, 2000, 1860, these are all leap years, and 1100, 1900, 1925, 2006 are not leap years. These are a few more things to keep in mind while solving the problems that we will be approaching. A 100-year span will have 5 odd days. A span of 200 years will have 3 odd days. A span of 300 years will have 1 odd day, whereas a span of 400, 800, 1200 and 1600 years will have 0 odd days. The justification for this can be seen here. 100 years will consist of 24 leap years and 76 non-leap years. Mathematically, when 100 is divided by 4, it should give 25. But since 100 is a century year and it is not divisible by 400, so 100 is a non-leap year. Thus, the total number of leap years will be 24. So each of these 24 leap years will constitute to 2 odd days. So the total number of odd days due to these 24 leap years will be 24 into 2. Each of these 76 non-leap years will constitute 1 odd day for each non-leap year. So the total number of odd days due to these 76 non-leap years is 76 into 1. Adding these two, we will get 124. But we need to see that if total number of odd days exceeds 7, further reduction is to be applied. It can be done by dividing the total number of odd days obtained by 7 and now finding the remainder. Thus, while the total number of odd days here obtained was 124, it is greater than 7. It has to be divided by 7, which will give the remainder as 5. So 124 will consist of 5 odd days. The number of complete weeks in these 124 odd days can be calculated as the quotient when 124 is divided by 7. Similarly, the case of 200 years and 300 years, the calculation part is same as that for 100 years. Now, for 400 years, it consists of 97 leap years because 400 is itself a leap year, as being a century year, it is divisible by 400. It will consist of 97 leap years and 403 non-leap years. Each of these 97 leap years will again contribute to 2 odd days, and these 403 non-leap years will contribute to 1 odd day each. Thus, the total number of odd days will be 497, which again exceeds 7. So, it has to be divided by 7, the quotient of which will give you the complete number of weeks, and the remainder of this will give you the total number of odd days. These are a few codes which are used to decide the day of the week. As I said before, the final number of odd days in our calculation should be less than 7. Now why did I say so? Because the codes to decide the day of the week lies between 0 to 6, where Sunday corresponds to 0, Monday 1, Tuesday 2, Wednesday 3, Thursday 4, Friday 5, and Saturday 6. Let us deal with the problems and questions and the way to approach those problems. Suppose we need to find the day of week on 19th December 1993. To solve such a problem, we first divide the given date into 2 parts. Part A will consist of the date till previous year, that is, the given date is 1993. So the part A will consist till 31st December 1992. Whereas part B will deal with the current year, that is 1st January 1993 to 19th December 1993. First we calculate the odd days due to part A. Now, the year 1992 can be broken up as 1600 plus 300 plus 92. Why this specific breakup? A thing which you must keep in mind is 1600 is the closest number to 1992, which is less than 1992 and divisible by 400. 1992 can be written down as 1600 plus 300 plus 92. This 92 can be further broken up as 23 plus 69, where 23 shows the number of leap years and 69 shows the number of non-leap years. Now we calculate the number of odd days due to these parts. As mentioned in the previous slides, the number of odd days due to 1600 is 0. The number of odd days due to 300 is 1. And the number of odd days due to each leap year is 2. So, for 23 leap years, the total number of odd days is 23 into 2. The total number of odd days for 69 non-leap years is 69 into 1. Adding all these, we get the total number of odd days as 0 plus 1 plus 46, that is 23 into 2 plus 69, which comes out as 116. But as I mentioned before, since 116 is greater than 7, it has to be divided by 7. The remainder will be 4. So 116 consists of 16 complete weeks plus 4 odd days. The total number of odd days due to part A is 4. Now, we calculate the odd days due to part B. The part B, which consists of the current year from 1st Jan to 19th December. The total number of days required for our calculation of part B can be calculated as 31 for January, 28th February, 31st March, 30th April and so on, which brings us to 19 days of December. This 19 because the last date that we have to find is 19 December, which gives us a result of 353. One thing to note, if the year would have been a leap year, this would be 29, since the number of days for February in a leap year is 29. Now, a shorter way to calculate the number of days in the current year is to subtract 12 from 365. These 12 will be the 12 remaining days of December, which as you can see will again lead to the result 353. Now, since 353 is again greater than 7, so it has to be divided by 7, which will give us the remainder as 3. The total number of odd days will be 3 and 50 complete weeks. The total number of odd days due to part B will be 3. Now we just have to add the total number of odd days for part A and part B. The total number of odd days, which we can see, is 4 plus 3, that's 7. But the codes that we have mentioned before are from 0 to 6. Thus, 7 has to be again divided by 7, and the remainder will give us the final code. So we can say, since 7 odd days make one complete week, 7 odd days will be equivalent to 0 odd days. According to the code mentioned before, 0 odd day corresponds to Sunday. Hence, 19 December 1993 was a Sunday. This surely can be verified from a calendar. This is the end of first part of the video series on calendar problems. For more types of problems and clarity, refer to the second and final part. Comment below for any query. Please like, share for more videos. Thank you.